have officially passed 2-3 minutes to allow people to connect. More will on connecting. So let me just briefly introduce this meet the EGEC members. So look at a bit the situation of EGEC. So today we'll present 5 new members. We will start presenting WellPerform, sorry. After we'll give the floor to Thermonet, then to Saipem, then to Future Pipe Industries, and last but not least to Vallourec. Membership. Today we are more than 230 members from 30 different countries, and you can see last year we reached the highest number of new members, 39 new members. So it was quite a successful year. And this year, in 2 months, we have already 7 to 8 new members. So the growing membership is continuing. You could see that from our membership, it's mainly industry, but we have also national association, which are national industry association mainly. So we have also them as members and some public entities being research universities, but also local surveys and other public entities. Membership from all over Europe, you can see that it's dominated where the geothermal market is also developed more than in other countries, so Germany, France, Italy, but in other countries we see a growing membership, especially in the UK recently. With that, it was a short introduction because what is more interesting for you is to hear the speakers. And I don't know if we start with Rasmus or Niels, but we fly to Denmark and to Netherlands to hear about WellPerform. Niels, floor is yours.
Yes, I can. I'm just sharing my screen at the moment. So good afternoon, everyone, and thank you for joining for today's webinar. Special thanks to the EGEC organization for hosting this event. And great to have so many industry professionals gathered here today. As said, my name is Niels Frinks. I'm a director of WellPerform and based in the Netherlands. I'm excited to introduce to you today WellPerform and share insights into our role in the geothermal industry. So WellPerform, we specialize in well engineering and project management, supporting geothermal, traditional oil and gas, and energy storage projects across Europe and beyond. With over 2 decades of experience in well construction and subsurface energy solutions, we've been actively involved in geothermal developments, helping out our clients design, plan, and execute wells efficiently and safely. So today I will provide an overview of our expertise, highlight key geothermal projects, and discuss how we can contribute to making geothermal energy a part of the energy transition. We look forward to sharing our knowledge and engaging with you during this Q&A session. So, WellPerform was founded in 2005 and is headquartered in Denmark. On the left-hand side, you can see the Danish headquarters. We have regional offices in Esbjerg, Denmark, Heerhugowaard, just close to Alkmaar in the Netherlands, Mumbai in India, and next to that, we have representatives in Germany as well. We have a comprehensive QA/QC management system in place and certified also to ISO 9000, 14000, and 18000 standards. Yeah, so we take pride in our spotless record. We're proud of that, having no recorded lost time injuries over the past 5 years, despite experiencing a significant increase in man hours during this period. And so we remain faithful in and commitment to develop a safe working environment. So here you can see an overview of the key business areas, some of which I will touch upon later in the presentation. So to WellPerform, customer satisfaction is a critical success factor. Therefore, it considers any project it undertakes, irrespective of the scope or size, to be of the highest level of importance. The focus, therefore, for us has been and will continue to be delivery of professional expertise in accordance with agreed goals and objectives with a high level of integrity and customer satisfactions. Those business areas are geothermal energy, upstream oil and gas, carbon storage, CO2, also hydrogen storage, and salt mining. Next slide. Corporate organization structure. As said earlier on, WellPerform headquarters and the regional offices within the WellPerform group, seen at the top. So we foster a culture of collaboration and synergies. To give you an example, every morning, the whole group, we start with our daily morning calls where we all entities meet online to talk about projects, objectives, and we share insights with each other. These regular interactions ensures that every department within our organization works pleasantly towards a common goal. The subservice team consists of WellPerform staff and being an integrated part within the engineering department. Everything under one roof. This allows for short lines of communications and easy access to necessary expertise. We view this setup as a key strength, allowing us to unburden our clients, not having multiple companies for your project management, but only one. Project supervision and resources management. We have a custom-built database. We allocate highly skilled professionals to our clients. We operate with our consultants and resources, the operational team. They maintain regular communications with them to see who's available, who's not. This tracking system allows WellPerform to quickly adapt to clients' needs by having an up-to-date overview and who is available for allocation. Everybody has a world map in their presentation, right? So this world map highlights the countries that we have successfully conducted business. You can see marked in blue the global presence that we have spanned multiple regions. We take pride of that and our ability to collaborate with different nationalities and cultures. This international experience that will strengthen us and our ability to bring valuable insights to new projects worldwide. We also have extensive experience in all aspects of upstream oil and gas, salt and geothermal projects, and over the years completed successfully over 600 wells and subservice projects for over 100 clients approximately. Yeah, you can see a table and just a graph of some of the recent projects that we've been working on, and some of them are still ongoing. You can see a combination of geothermal and CCS. Yeah, keeping our customers happy is key to our success. Again, we treat every project, big or small, as a priority. So our core business, well engineering. Well engineering department is dedicated to the design, construction and maintenance of wells with a strong focus on innovation and efficiency. Our team of expert engineers leverages cutting-edge technologies and industry best practices to develop tailored solutions for every project, for every client. There's some key bullet points there: casing and design and material selection, well trajectory design and planning, and a completion design. What's good to know is that WellPerform, we own licenses for industry software. That software is built into our rates, no hidden cost afterwards, and then you need to think about Landmark, WellCat, WellPlan, Compass, those kind of softwares that we offer to our clients. The subsurface department, explained earlier on, a vital role in our company. They specialized in reservoir characterizations, modeling, and management. So by leveraging advanced geological and geophysical techniques, our team provides valuable insights into subsurface conditions, enabling informed decision making and maximizing reservoir performance. So our global presence is more than just a footprint. It's a platform of innovation and collaboration. By working across multiple regions and industries, we continuously exchange knowledge, adapt best practices, and drive technological advancements that enhance well engineering and project execution. One good example is the current project GeoThermal in the Netherlands, which is led by Geothermal Netherlands, EBN, state-owned, and TNO. In that project, 23 parties gather for the geothermal sector and jointly working on a broad innovation program called GeoThermal. The research themes aim to deliver results that will increase geothermal energy production at a lower cost. WellPerform has been asked by the Geothermal Association to participate in this program, and we do, and we contribute by well engineering analysis and insights. Outcome is to optimize geothermal wells in tight reservoirs. That is it from my end.
Thank you, Niels. A really clear presentation. Thank you for all these details about WellPerform and your activities in Netherlands, Denmark, but also all over the world we have seen. So if you have questions to Niels, feel free to use the Q&A, the chat also, and we will answer them at a later stage. I'm now giving the floor to Thermonet, and I will ask Bjørn to present Thermonet. Bjørn, the floor is yours.
Thank you, Philip. Do you see my slide? I think you see my slide now, right?
I confirm, yes.
Yeah. You can't hear me? Can you hear me?
Yes, also I confirm.
Good. Thank you very much. I'm happy to be able to present. I'm here on behalf of Thermonet Denmark, and our international name is Thermonet Europe. We consider Thermonet to be a generic term. I'll come back to that. So my name is Bjørn Andersen. I'm affiliated with Thermonet Denmark, which is an NGO, geodrilling, which is commercial, and a local energy community where I live. I have a background as a business journalist and a communications advisor. I'm a communicator. I have a lifelong involvement with green transition and co-founded Thermonet Denmark in 2020. Now on a part-time contract. I'm here today because our founding chair was unable to attend, Søren Skjold Andersen. Some of you may know him. Thermonet Denmark is a non-profit association. We promote the spread and development of thermonets in Europe and Denmark. As I mentioned, we consider thermonet a generic term, much like the internet. Heat pumps are coming, both on the small and the large scale. We want them connected with pipes on the cold side. And we focus on synergies between heating and mainly passive cooling, primarily based on shallow geothermal. We want thermonets to enjoy the same benefits as traditional district heating. I'll come back to that. We have 83 organizational members, almost all of them Danish, and they range from consultants to manufacturers to advisors, public authorities on both local and regional and national levels, and some NGOs and local energy communities. And we have basically gathered the people that think this is a great idea, and we work together. And we're still growing. We have raised awareness of what we call Thermonet. I'll come back to the definition shortly. Starting from 0 5 years ago, now we have several thousand unique visitors per month on our website. We have even managed, Google tells me, to make the Danish Parliament mention Thermonet or Thermonet 163 times. I'm not sure they have understood it quite yet, most of them, but we're working on it. And we have come to see that a lot of the things we work with are relevant on a European level. So what is a Thermonet? You should be able to see my cursor also now. A Thermonet is an underground distribution grid which transports geothermal and other thermal energy from one or more energy buildings at a temperature relatively close to ground temperature. In other words, it's the pipes that connect energy sources. We have them here. I'll come back, but you can see well and horizontal uptake here. There are other options as well. So we connect energy sources with the cold side of the heat pumps. They can be decentralized in single houses, as you see here, or they can be large megawatt scale heat pumps that then connect to existing district heating with insulated pipes. So again, the Thermonet is the uninsulated pipes. That's it. And what does it look like? Here are the plastic pipes. They are similar to those used for drinking water, and they are connected using the principles known from district heating. We require a larger internal pipe diameter than conventional district heating because we work with much smaller temperature differences. It's attractive to exchange energy with the ground, at least in the temperate climates, so there's no need for insulation, which means that the total pipe diameter is smaller than conventional district heating. And when laying the pipes, controlled horizontal drilling may be an option, which it is not when you work with steel pipes. You can see we use blue colors here. This is not the best. We are working with pipe manufacturers, some of which are members now, to find a better color and maybe also some signs of directional indicator on the pipes. So in Denmark, district heating is widespread. We are above 60%, which is relatively unique in Europe. The proposal with Thermonets is that we could take collective supply of heating and cooling now also even further. For the ordinary consumer, the traditional choice is between district heating and individual heat pumps, which will typically be outsourced. If we could enable Thermonets, we could come out in rural areas because the economics and the heat loss profiles of Thermonet grids are way different from conventional district heating. Unfortunately, the Danish Parliament last year decided not to remove the option for public loan guarantees that are available for conventional district heating, but not for Thermonets. So we are looking very much to the EU level to figure out how to crack this and get it going. This is a map of screenings in Denmark. The blue dots are already established Thermonets. The green, light and dark ones are potential Thermonets. And all the places you don't see any dots is why people haven't been looking yet. No screening there. So some municipalities have screened, others have not. This picture could be replicated Europe-wide. The potential for Thermonets and shallow geothermal is basically almost everywhere. Looking out, we have a map of what has already been done in Germany, and you can follow the links here to get some examples of what's going on in the US and in the UK. A lot of stuff is going on in the UK, especially headed by the Kinzer Group. Why is this interesting? The thing with cooling. Cooling will be the main driving force for shallow geothermal. And this is an example from a Danish modern house where you see an office, the red line at the top, with no cooling. It gets too hot in the summer, simply, even up here in the northern climate. If you apply passive cooling, meaning not using the heat pump, you can keep a decent temperature in the summer. We have made a list of all the possible additional energy sources that can be used, but of course the most important ones are the shallow geothermal ones. You can study this later on from the slides. And we have this listed on our website also, if you can deal with machine translation of Danish so far. Just a few examples of how far. Here's a lighthouse project. The so far biggest is a village with 55 retrofitted houses coming from oil boilers to Thermonet. And this project, which is a little west of Copenhagen, was done by a consumer-owned district heating company. And there is a link to a machine-translated case description here. Here is another very innovative example where the Thermonet is built into the roadbed. So it's underneath the roadbed. It's not taking up space on its own for the horizontal uptake. There are vertical boreholes as well, and heat is extracted from the sewage line. And this is what it looks like when it's being built. And afterwards, it's quite conventional housing, as you can see. These are rentals. So we are proposing to go with Thermonet as a name for the pipes that connect heat pumps on the cold side, combined with shallow geothermal. This currently has a lot of different names, and you probably know or maybe even use some of these down here. This is a simple moniker that people will understand, or at least think they understand. A bit like the internet, we think we understand it. I'm not quite sure yet. You can read more or join us at our provisional European website. We are morphing into a European organization, and we have a strategy for that. We very much want to get in touch with someone, with some those of you that could be interested in being part of that process. So you can contact us on this address, contact@thermonet.eu. Thank you.
Thank you, Bjørn. And I see there's a question to you. For Thermonet, have you looked at synergies with cooling PVT panels to heat boreholes? For example, 3 to 5% increase in electrical output per 10 degrees cooling.
Yes, this is very much an option, and there are small projects working with it, and it's part of the list of 25 possible energy sources I showed.
Thank you, Bjørn. And I have more questions to you. I don't see any from, maybe it will come at a later stage. So it's time to give the floor to Mariella and Leporini to hear more about Saipem and what Saipem is doing now in geothermal. So we fly from Denmark to Italy and we give you the floor.
Yes, thank you, Philippe. Can you see my screen, my presentation?
No, it's perfect. We just have a small black box at the top of your slide.
Hoping that is coming. Can you?
If you move to the next slide, we can see if it's still there or not.
Because we tried before and it worked.
Well, anyway, it's not disrupting.
Yet.
So, no, but no, I think you can move on because it's not disturbing your presentation. So you can move on. Floor is yours.
Ah, okay. Is the
Mariella, we
now?
can see your presentation.
Okay. Now?
It's better.
Okay.
You can speak, yes, no problem.
Okay, okay. Thank you so much. So, thank you, Philippe. Good afternoon, everyone. My name is Mariella Leporini, and I am Geothermal Energy Product Manager at Saipem. I got a PhD in energy science, and I have more than 15 years in the energy industry sector. Who is Saipem and what does it do? We are a global leader in the engineering and construction of major projects for the energy and infrastructure sectors, both offshore and onshore. But not everyone immediately associates us with geothermal energy. So before telling you about our value proposition in the geothermal sector, first I would like to give you an overview of Saipem. We are a one company with unique expertise, strong technological innovation capabilities, and advanced high-tech assets dedicated to identifying and developing diverse solutions to support our clients in building a sustainable business. We are always oriented towards technological innovation, and our purpose is engineering for a sustainable future. We enhance creative talent and prioritize the health and safety of our people, communities, and environment. We are dedicated to fostering relationships built on trust, embracing diversity, and promoting inclusivity. Okay. We have a presence in more than 50 countries and approximately 30,000 employees from 120 nationalities, with 6 prefabrication yards, focused on, of course, prefabrication, assembling and erection operations of large and complex manufactures. We have engineering centers indicated in this picture by yellow dot, dedicated to research and development, business, process management, and information technology. And our global presence is also complemented by other relevant sites. In 2024, we had a revenue of more than 14,500 million euros. And Saipem generates economic value through its activity and redistributes part of this value by contributing to the economic growth of the countries and communities where we operate. Regarding our sustainability plan, we adhere to the United Nations Global Compact, committed to contributing to the achievement of the Sustainable Development Goals of the UN 2030 Agenda. And our 2025-2028 sustainability plan is based on the pillars of climate change mitigation, environmental protection, people centricity, and value creation. We have received key recognition in the field of sustainability, and we consider HSE culture as a key driver. We have a foundation to spread health and safety culture in the industry and society. The foundation promotes safety culture in the workplace and international best practice through training, campaigns, and cultural initiatives aimed at both general public and industrial operators. We have our net zero program with carbon neutrality for scope 2 emissions by 2025 and net zero for scope 1, 2, and 3 emissions by 2050. Operating on the reduction of the carbon footprint of our assets and supporting clients to reduce their carbon footprint. Let's move now on the topic of the geothermal energy. Saipem began its activity in the geothermal sector as a drilling contractor as early as the 1970s and 1980s, carrying out exploratory wells in various permits within the Enel Eni joint venture in Italy. Later, in the 1990s, we drilled exploratory geothermal wells in Italy for Enel. Additionally, Aquater, an environmental engineering company within the Eni group and now part of Saipem, provided exploration and production services in the geothermal sector for over 25 years across Europe, Africa, Asia, and Americas. Overall, we have contributed to the development of at least 40 geothermal wells worldwide, And we have more than 80 publications in the area of geothermal energy. For example, Aquater, in collaboration with the Lawrence Berkeley National Laboratory and the Institute of Geoscience and Earth Resources of the National Research Council of Italy, developed the thermodynamic model for the geothermal field behavior. And this model was later updated by Saipem in partnership with the other two companies. From 2011 to 2018, we resumed providing engineering services around the world, Kenya, Turkey, Indonesia, to characterize geothermal resources, define the development of production areas, and offer technical assistance during the planning and project management phases. Today, Saipem recognizes expertise within the oil and gas sector in drilling as well as in constructing large-scale plants and fluid transport system can be, and we want to successfully repurpose in geothermal energy, enabling us to operate along the entire value chain to meet the needs for our customer with a view to a sustainable business. We are embracing the challenge of the energy transition by developing innovative solutions for the energy sector in line with the net zero 2050 goal. Geothermal energy plays a strategic role in our energy mix for a sustainable transition. With a track record of over 5,000 wells drilled onshore, 130,000 kilometers of designed and installed onshore pipelines, and 10,000 megawatts of power plants built, Saipem is a reliable technical partner to manage and control all the geothermal value chain. Many of the skills, tools and infrastructure originally developed for hydrocarbon extraction are directly applicable to the exploitation of geothermal resources, enabling cost reductions and greater efficiency in both well construction and management, as well as in the design and construction of surface infrastructure. Saipem's strategy for geothermal energy also relies on synergies with other key technologies for decarbonization in the coming years. A central role is the technological hybridization. The integration of projects and technologies already close to market deployment, such as CO2 capture along the CCS value chain, combined with low and medium enthalpy geothermal energy, can play a crucial role in advancing decarbonization. In this context, Saipem's enzymatic blue enzyme technology for carbon capture, designed to leverage recoverable heat from low and medium temperature sources, addresses this challenge by using geothermal energy as the process power source, further reducing emission. This concept is concretely applied in the Capture S project developed by ERA Group and Saipem in Italy, which was recently selected by the European Commission to receive nearly 24 million euros in funding from the Innovation Fund, with the goal of promoting the deployment of cutting-edge clean technologies in Europe. The project will enable, in fact, the capture of CO2 from a waste-to-energy plant, exploiting renewable energy, both generated from the waste-to-energy plant itself and from geothermal heat delivered through the multi-utilities district heating network. Another tangible example of technological hybridization is the extraction of lithium and other strategic minerals from geothermal brines, integrating energy production with resource recovery. By incorporating mineral recovery processes into geothermal energy production, it is possible to generate clean energy while extracting critical raw materials essential for green but also digital technologies. Looking to the future, more or less 2 years ago, we launched a research and development program to unlock also new geothermal resources beyond conventional technical and geographical boundaries, in line with global decarbonization priorities. This initiative focuses on the repurposing of depleted oil and gas wells for geothermal application, the development of next generation geothermal system, and the exploration of offshore geothermal energy as an innovative energy source. Through these initiatives, Saipem continues to confirm its commitment to the energy transition, providing innovative and sustainable solutions for a low carbon future. Thank you.
Thank you, Mariella. Really clear
You're
presentation about Saipem and your long experience to transfer technologies from oil and gas to geothermal and CCS. Do we have questions to Saipem? Please use the Q&A. You can raise your hand if you want to ask an oral question, also the chat. No, I just maybe have a question for you, Maria, because you mentioned last week in Rome at the Italian Forum, the project you have with the city of Ferrara. Maybe you can a bit explain to the ones, because maybe you don't know, but it's another project funded by the Innovation Fund and Saipem is part of it.
Yes, Philippe, do you want that I can explain also a little bit more the event that we had in Rome?
No, maybe just the project, I think.
Just the project, yes. As anticipated, the project was selected by an Innovation Fund. It was granted by Innovation Fund for the combination of CO2 capture technology with medium, because in this case it's a medium geothermal energy. As we have we have our own technology based on an enzyme that needs more or less 80 degrees to works, and this is absolutely an example on how the heat needed for the carbon capture process can be used in a more sustainable way. So geothermal energy used to feed a carbon capture process will lower both the carbon footprint and the cost of CCS itself. So we applied with ERA Group. ERA Group applied as a main partner. We applied with the ERA Group to Innovation Fund for this concept, and the project was selected, awarded, and also the replicability of the project was voted with a very high score.
Thank you, Maria. Indeed, really interesting project, and we look forward to see the successful development of it, and maybe to organize a visit there or another.
Yeah, for the future.
The fantastic city of Ferrara.
Absolutely. Thank you, Philippe.
Okay, and now we fly from Italy, and we give the floor to Carlos from Future Pipe Industry. So we stay a bit in the pipes, and we ask him to present better Future Pipe Industry. So if Maya, you stop sharing, Carlos can start sharing.
Can you hear me?
Okay, we can see your slide, Carlos, so the floor is yours.
Can you hear me?
Yes, but the sound is really low. If you can maybe...
Sound is low?
Yeah, if you can be closer to your mic.
Yeah. If I can set up properly. Now better, I guess?
A little better, but not fantastic. Or maybe I'll ask all of you to increase the sound of your computer so we can hear Carlos. Carlos, the floor is yours.
Yeah. Can you hear me better now? Or?
Yeah, it's better now.
Better now, okay. So good afternoon, everyone. It's a pleasure to be here today as part of the EGEC webinar. My name is Carlos Escobar, and I represent Future Pipe Industries as a business development manager for Europe, covering energy, industrial, and geothermal sectors, being in the non-metallic business for more than 14 years. So today I will be presenting how non-metallic solutions, composite piping systems, are transforming geothermal well design by offering enhanced durability and corrosion resistant and sustainable solutions. Future Pipe Industries has a strong legacy of over 40 years in composite piping solutions, serving energy, industrial, and water markets worldwide. FPI is the reference in a non-metallic solution across Europe, providing a full integrated composite piping and coupling system with manufacturing capabilities inside EU, in South Europe, exactly in the Netherlands. We have a strong presence across 50 countries and in all the continents, with more than 20 sales offices, 14 factories, and 53 production lines, and more than 4,000 employees. These capabilities enable us to deliver high-performance, sustainable piping solutions for geothermal industry and other segments, as mentioned, reinforcing our commitment to innovation and operational excellence. We cover 4 key sectors: energy, chemical and industrial, water infrastructure, and marine and offshore. Each sector represents with specific products, showcasing our versatile and expertise. The detailed list that is shown in the slide accompanied with images illustrates our commitment to meeting diverse industry needs, from water transmission systems to industrial pipelines and piping solutions. FPI is a worldwide leader in product offering when we can offer full range of composites material, meaning GRE, epoxy, GRB, vinyl ester, and GRP polyester. Non-metallic downhole tubing and casing for thermal wells, particularly those which are low enthalpy, which will be under our GRE material, which later on I will be explaining in detail. Non-metallic solutions offer significantly advantage, such as reduced corrosion and enhanced durability, making them ideal for challenging downhole environments. This innovation is crucial for advancing geothermal energy extraction and moving towards a greener and more sustainable future. Inside the geothermal segment, FPI is delivering composite solution in surface piping, industrial piping, district heating, district cooling and transmission lines, and also downhole, doublets and deviated wells up to 2,400 meter depth. It's versatile across various temperature ranges, underscoring our commitment to provide compliant and effective solution in diverse and severe application and harsh environments. When we'll talk about GeoStrong, that is our branding name, is tubing and casing product designed for various well applications, including production and injection wells. This slide emphasizes the importance of this solution in municipal and commercial water wells, showcasing our comprehensive approach in geothermal energy, utilizing what it can be seen breakdown into the services that we are working. Our GeoStrong, our brand name that we have for surface application, as mentioned before, both products are glass reinforced epoxy, also known as GRE, which is a composite material consisting of glass and or carbon fiber, as we'll see later, reinforcement embedded into an epoxy resin matrix. This combination results in a high strength, corrosion resistant, and lightweight alternative to traditional metallic tubulars. Let's introduce three types of well designs where FPI is acting and ensuring the integrity and efficiency of the thermal wells. The first one is in that schematics is a detailed design where dedicated full composite completion string. Key components here is that at the end there is a PBR for sealing an annulus that it's having a 24/7 monitorable management system being under pressure. This design is crucial to maintain the well integrity and optimizing the performance. This cross-section views and provides a clear understanding how these elements work together to enhance geothermal, where functionality and GRE is acting inside this schematic as tubing. The second one, and continue the well design, we are focusing on full composite liner or protection string. The detailed diagram illustrates layering of material, including cement and carbon steel casing, which are essential for ensuring the structural integrity of the well. And this design is vital for protecting reservoirs and enhancing the longevity and geothermal system. As in that schematic, FPI is acting as a GRE liner. Last but not least is the third well schematic, showcasing a full composite casing from wellhead to reservoir, being a funded EU project, Geothermica, in consortium with other 4 companies that has been finished and taking us during the last 4 years. This design verified at the end of the GRGO project that our advanced engineering behind our geothermal solution, exploring a non-metallic casing tubing on GRE, and commitment to quality and innovation and well construction. Composite tubular are essential for reducing weight and improving resistance, harsh conditions, and making them preferred choice of the industry. This product is an engineering product with advanced materials, including aromatic amine curic epoxy, as mentioned before, and corrosion-resistant e-glasses, ensuring high performance in various well types. The specifications are listed, such as the pressure ratings and temperature resistance, underline the versatility and reliability of our offering in the geothermal sector. The GeoStrong threaded joints detail our patented 4-round thread jointing system has an option available, including full glass fiber or hybrid coupler, where we are combining in the same coupler carbon and glass fiber to reduce the OD of the coupler, maximizing the production. All are designed to enhance the portability and the performance. When exploring the various applications of non-metallics materials in downhole settings, let's go deep into it. Some of them are already listed, as you can see, disposal and injection wells, as well as liner for repairing corroded steel casing. This highlights the versatility of non-metallic solution, addressing common challenges in the industry, particularly in geothermal wells, where low enthalpy conditions prevail in salty well reservoirs. On top of the tubulars and the coupler, FPI can deliver full non-metallic solution, and that's why we are presenting this slide where in that images it can be illustrate how easy is the installation process of a FPI tubulars and introducing non-metallic crossovers. As you see, it's quite easy to highlight how practical and easy it can be deployed with a standard tooling, and the same rig setup. Images have shown the versatility of maximizing different elements under GRE, making a customized design fitting into the purpose. Where using the hybrid coupler, you may see the outside flash connection where there is no transition in OD measures between the tubular and the coupler. Conventional metallic materials and their associated capex costs. Metallic represents higher lifetime costs in short lifespans, and materials like carbon steel and nickel alloys, emphasizing the financial implication of corrosion and maintenance. This analysis underscores the needs of more sustainable and cost-effective solutions in the industry, paving the way of adoption of composite materials. When coming into the OPEX, costs associated with metallic materials, it is worth it to emphasize the maintenance and protection required to mitigate the corrosion, the high life cycle costs, and the metallic solution, and contrasted with the benefits of the composites, which reduce the workover activities and overall operational costs. This visual comparison shows and illustrates the financial advantages of adopting composite technologies in downhole application, having an efficient warranty during all the design life of the well design, which, as per FPI product design, it can go at least up to 25 years design life. To summarize here, there are the benefits of using glass reinforced epoxy and the advantages are listed, such as the corrosion resistance and reduced weight, highlight and the practical benefits of GRE in the oil and gas application, and the emphasis of environmental safety and lower heat loss further the strength that case for adopting non-metallic solutions, showcasing the potential to enhance the efficiency and sustainability to the industry. And more important, when we are talking about a green energy, we're trying to adopt the greenest solution as possible. At Future Pipe Industries, we are proud to be at the forefront of the non-metallic technology, delivering a composite solution for not only to extend the lifetime of the geothermal wells, also to reduce the operational costs and environmental impact. We are committed to collaborate with the industry leaders, engineers, and developers to dive into the next generation of geothermal industry. I want to thank you once again to the EGEC. I'm looking forward to continue the discussion, answering any questions that you may have.
Thank you, Carlos, for this detailed presentation on the product of Future Pipe Industries. I'm sure there are some questions also to you. I just have a clarification. You mentioned that the depth maximum is 2.2 kilometers around. Of course, it will depend on the geology. Regarding the boundaries for the temperature.
Yeah. So the maximum temperatures that we can be withstand in our GRE solution, maximum is 100 degrees. So that's why we are targeting the low enthalpy, and that's why we have emphasized. So we are not in the energy part. We are more in the, as we say, in the low enthalpy. So more into the into that segment, having this. Although we are working in order to enhance our products and trying to achieve higher temperatures, where we are targeting up to 150 degrees.
Okay, so it's a research ongoing.
Yeah, nowadays, our current offering is maximum 100 degrees, as mentioned.
Perfect, thank you. Don't know if you have questions, but if not, maybe let's continue this discussion about pipes and give the floor to Maximilien from Vallourec, and after maybe in the Q&A we can have a further discussion about pipes, because there's a lot of expert in this underground topic in this panel. So, but let's give the floor first to Maximilien to hear from Vallourec, and after come back to the discussion. We can see your screen, not yet in full screen mode. It's ongoing. You're still muted, Maximilien.
So now you should hear me.
Yes, and we see your slide in full screen mode, so floor is yours.
Perfect. So my name is Maximilien Maisonneuve. I'm the head of the geothermal product line at Vallourec, and I'll try to explain what we are doing with our customer to leverage the decades of oil and gas expertise to help customer to improve the well integrity. So quick introduction of Vallourec. Our ambition is definitely to be part of this energy transition and to make it a reality. And as you can see, this picture is showing some forest, because Vallourec started this journey a long time ago, like 25 years ago, trying to reduce the footprint of our mills. And we are now moving to this new energy horizon. What we want to be, definitely a technology leader, integrated manufacturer, also for sustainability, the best in class, and last, becoming the partner of choice for our customer, whatever the industry our customer are. Today, Vallourec, it's around 15,000 employees, more than 5 billion revenue. But it's more this more than 100 years of expertise and all the R&D team that are working actively every year to develop really this cutting edge solution for all those industry we are in. Mainly 4 sectors. Vallourec is well known in the oil and gas industry with the brand VAM, but also very present in the industry, and also because of our local presence in Brazil with our iron ore mine present in this business. But the new business we are targeting now for the last 5 years is to develop this new energy business and follow the development of those markets. So for hydrogen, geothermal and carbon capture market. That's our local presence. The main manufacturing footprint are definitely in Brazil, as I mentioned before, followed by the US. And then we have some finishing capacity in France, Saudi Arabia, and China and Indonesia, so a global footprint. And we have also some unique tools, for example, in France, where we manufacture pipe with a radial forge, which enables very customized and shaped product for several industries. We have also, as I mentioned before, 3 R&D centers in Brazil, in France, in the US, and to support our customer in the development of their needs. And the main topics also regarding VAM is the presence of licenses, so workshop that can take care of VAM product in case of needs of repairs or accessories, so spread all around the world. Now talking about the sustainability, we made this exercise to see where the CO2 emission were coming from. And as you can see, part is from the raw material, but we are using more and more scrap in our, definitely recycling material as the origin of the steel we are making, but still using our mine in Brazil. And then the biggest contributor of CO2 emission is the steel making, but we are working on using more and more renewable energy in our facilities to reduce this portion of it. Then we have the finishing and the tube manufacturing, which represent another quarter of the emission. And the logistic, as you can see, despite the image that those pipes are traveling around the world, this is a small part of the footprint. And we've achieved good results in terms of tons of CO2 per tons of pipe, going from 1.8 to 1.45 recently, so reaching a best-in-class footprint. And today, for geothermal operators, this is a key element. They are definitely asking us to explain and to show the audited figures. Same for the steel, but as we are not delivering steel to our customer, but pipes, we mostly focus on this footprint. So as I said, I'm part of this new energy product line, and for those new energy business, we took all the product that could be applicable for those 3 application and tested them in the different condition. So in the case of geothermal wells, what we did recently was definitely to test to higher temperature. I will come back on this later. Corrosion also. And for example, just to give some quick example, in case of depressurization of CO2, you can reach minus 70 degrees temperature, and we tested our product in this condition to give the warranty to customer that they can use. Same for small molecules as hydrogen. For geothermal, what we are targeting, that's probably a bit different from my predecessor, is definitely very deep, and the hotter, probably the more challenge we will face for conventional geothermal, but also we are working very actively on the next generation of geothermal systems, so enhanced geothermal system and advanced geothermal system, where fracking brings, and long lateral brings a new challenge, or closed loop system also needs a very specific product for that. So we start from customer needs, as discussed before by FPI. So corrosion is the main topic for sure in geothermal. So we help our customer on that. But when our customers are going deeper and deeper, they see also more and more collapse issue that is reducing drastically their production. They see a lot of thermal derating. The more you go beyond 200 degrees, the more the property of the steel is reduced. We see scaling, and then is no new geothermal system, next-gen system. Because of fracking, you need to increase a lot the burst resistance, and the torque also that is needed to go and install those casing are key. So we are making a well design with our customer to help them to choose the right well design to achieve the installation of those products. So regarding material selection, usually what we do together with our customer is to understand their downhole condition. So getting the data from our customer for bottom hole temperature or all the gas analysis of their brine, the composition, the pressure, the pH, and so on. So we use all of those data first, making a first selection using some dedicated software and comparing with our database. We choose the best material, and then we together with our customer, we select what we want to test first in our lab, and second, we also do the testing and then the analysis of those coupons that are put on site, and to evaluate what is a potential lifetime of the different material that have been tested. So that's key for well design for customers. Then we also use what has been developed for high pressure oil and gas wells, which is called high collapse grade. And the benefit of this product, which is used mainly by a tighter production control, is to achieve using the same well design in terms of dimension, but moving to those high collapse grade, you can achieve a much better resistance. So if you take a very standard size of 958, you go up to 94% compared to the very standard product that is today used in the industry as a K55. So it means by changing this without changing the operations or even the installation, the safety factor for customer it's much higher. Same for connection. Vallourec have been developing a gas type connection for more than 70 years now. So VAM is definitely the leading connection on the market. So we use the most recent one, which is called VAM 21. And we tested it at the top temperature, which is today 250 degrees Celsius, through a very normative thermal well casing connection evaluation protocol called TWCCEP. And we are making some tests in our lab cycle to make some temperature cycles and see how the product resists, and not showing the example of this railway that are completely deformed, but making those analyses of deformation of a wells of 2,000 meters at 250 degrees. Casing can expand up to 8 meters. So you can imagine the challenge this brings to our customer. Why we did that? Because today the API product are going up to 180. Some customer in the oil and gas were going up to 240 for HPHT wells, so high pressure, high temperature wells. But some customer today, as you can see in this Rystad forecast, are exploring or developing fields higher and higher. The dark red is above 250 degrees C. So you see the mixed, especially for power, increasing towards a higher temperature. So that's why we move this frontier testing product with customer up to 350 degrees. So this frontier is today validated, but now customer, as they are very smart and very ambitious, they want us to work on this for this new frontier to 450 degrees. So we are part of those working group to develop those products for definitely very challenging application, but in terms of power output, very efficient and very important power generation product. So we do that all internally in our facilities. Customer comes and visit to do this testing together, and this is what we've done in the past years. I mentioned also the next gen support. So what we are doing is help customer choosing the right well design, right product, and steel grade to be able to achieve a very long lateral design. So Vallourec, being part of the shell revolution in the last 15 years, we try to apply the same I would say methodology to help those enhanced geothermal system to develop more powerful system and more I would say economical design, complete system design. Regarding closed loop, we are working both on the coaxial wells. You see the product on the right is this Thermonet, which is a kind of thermos bottle, same system. You have vacuum between two pipes. This product has been on the market for like 4 decades, and customers or startups that developed this kind of design came to us and asked us to co-design with them their system to make sure you can have the cold water going inside the casing and the hot water inside this thermocase vacuum insulated tubing in the middle of this casing, and as this flow bringing heat to the surface, sometimes with water. Customer tested other fluids to carry heat, and we also work with company like Eva for those multilateral design, and other customer working on very deeper than 6 kilometer wells today all over the place, as you know that they want to bring geothermal everywhere. So Vallourec team is really happy to work really in an advanced phase to support large corporation, but also very small startup to find the best solution to finalize their design, and sometimes bring some ideas to a full design and a workable solution. So this is what we are doing today for geothermal, and the team is really passionate to find solution for this market. It can be for district heating, for power. Some customers today are very active on lithium extraction, as mentioned before, because it's improved a lot the economical equation of projects. So this is what Vallourec is proud of doing with customer. And last but not least, I already mentioned it, probably the next frontier, we'll see how this will become operational, is the super dry rock project. It seems crazy for the time being, but we are sure that the industry, supported by many oil and gas companies, can find solution to explore those new markets for geothermal. So that's all for me. Don't hesitate to contact me if needed, and if there is any question, I will be more than happy to answer.
Thank you, Maximilien, for this overview of Vallourec products for geothermal. Indeed, let's enter now the Q&A session. And I see, Mariella, there were a question to you, but we have not yet answered. So I ask all presenters to also, if you have a question to another one, feel free to use it, the Q&A session, and also to all attendees, it's time now for the Q&A session. So Mariella, do you have involvement in France, and do you have a colleague in charge of geothermal and CCS by Saipem France?
Yes, for sure. We have our Saipem SA in France, and we are strictly connected with the innovation function and all the structure in France. So if there is the possibility to exchange, have a confrontation meeting with them, we have, and we can arrange organize.
If you want, you can go to a Q&A session, and there's the contact of the person asking you this question.
Okay. Thank you, and I will do.
Do we have more questions to the interveners? And looking at the chat and the Q&A session. No question? Although we had so many interesting products, or maybe between presenters, if you have a question to our presenter, feel free to question.
Yes, for me, Philippe, I know you are very active in building standards for the industry in Europe, because I definitely convinced this will make permitting much more efficient and faster, and probably avoid issue we could have faced in France or in Switzerland in the past, because you avoid to make a mistake that can block a project for years. So how do you see the development of those standards? I know there are some working group on that.
So we just indeed used WellPerform, the largest trade fair in Europe, in Gothenburg at Geotherm, to launch the working group to see an interest from our members on this topic. And indeed, there's an interest. So we are looking at all technologies, of course, from geothermal heat pumps to deep geothermal for district heating or electricity. And we do an overview. First result of overview that there's already quite a lot of standards from API and drilling, from ISO. You mentioned some of them here, Maximilien. What we probably miss is guidelines and code of best practices for different activities to accompany, notably some developers. When we speak about small developers, cities, how to accompany them. So it's notably in the drilling phase for sure, but not only in the project management. We are looking at, of course, Bjørn for fifth generation district heating, for geothermal heat pumps. We look at also different kind of guidelines on permitting, or to simplify permitting, also with standard processes. We are just in the phase of data collection. So if you have any data, come back to us. We plan to close this data collection phase around mid-April, end of April. And from that, we will have a second meeting, probably online, working group meeting, to see indeed what is the next step.
And do you have the same for certification of people working in our industry? I'm thinking about well design, about drillers.
So for certification in European legislation is only focusing on small scale certification. So we speak about drillers for shallow geothermal. For deep drilling, we don't have yet this. We expect deep collaboration with IDC, with SPE and other world entities to see how there's a need first. Maximilien, I don't know if there's a need to have certification of driller. We are sure there's a need of training, upskilling and reskilling to have more workforce, skilled workforce. The certification, I'm not expert in this topic, but open to discuss it.
But the certification is probably a way to bring new resource well trained.
Sure. Certification, probably we need to detail what we mean by certification, because in shallow geothermal drilling, certification is a strict process, where after it will be obligatory to drill a project and to ensure quality with a national certification authority. Markets are mainly national in shallow geothermal in drilling. In deep drilling, we speak more at global market. So it will be beyond Europe, probably, the discussion. And we have to see, indeed, when there's training, education, there's a certification, but how we can ensure also in upskilling certification. I'm not expert in the topic, but let's look at it.
Thank you, Philippe.
Do we have more questions?